Welcome children, welcome back to Physics and Chemistry Made Easy. Today our topic is about atomic structure. In that we will see information skill questions. So one by one we'll see few information skill questions, almost around 5. So the first one is on the board. The question is electronic configuration is given and the electrons are also filled in the orbitals. So degenerate orbitals. So the first one is 1s2, 2s2, 2p3 and these electrons are also filled in the degenerate orbitals. First case 2, then 2 and it is 2p3, therefore you find here 3. And B, question B is other electronic configuration for element 20 is given. 1s2, 2s2, 2p6, 3s2, 3p6 and 3d2. Then coming to third one is helium with atomic number 2. Electronic configuration is 1s2 and 2 electrons are filled in the degenerate orbitals. Each degenerate orbital holds 2 electrons. So, okay, fine. Now, these are the following questions. 4 questions are given. Generally, you find 4 questions in information skill question. Each one will carry 1 mark and it will be for 4 marks. So, the first question is what? Which one violates the above principle? So he is speaking about Above principle. The incoming electron should occupy the lowest energy state first. Next one is which one violates the Hund's rule? Hund's rule means what? Pairing occurs only when all the degenerate orbitals are completely filled with 1 electron each. If suppose you have 4 electrons and p orbital means 3 degenerate orbitals, you have to fill 1 each, then go for pairing. Okay, done. And third one is which one is violating Pauli's exclusive principle. No 2 electrons should have all the 4 quantum numbers same. That is what Pauli's exclusive principle states. And then if there is any wrong among A, B, C, correct the electronic configuration. So if anything is wrong in these 3, he is asking us to correct. Now before you start giving the answers, good thing is what you need to work out something for the sake of answers. And the first one, let us take first one. What is given here? 1s2, 2s2 and it is 2p3. And then he has filled them into orbitals. So 1s means first one. Okay, first one 2 electrons 1, 2. Second 2 electrons 1, 2. Third case p there are 3 degenerate orbitals. So first one here, second one here and third one here, isn't it? Because these are just 3. Now what happened here? He paid first one. So what is violated here? Pairing occurs only when all the degenerate orbitals are completely filled with 1 electron each. But what happened? Altogether 3 are there. He paid in the first one. So this Hund's rule is broken here. Hund's rule is violated. Right, this is about first one. Now coming to second one. Second one. 1s2, 2s2, 2p6, 3s2. It is for 20. Okay, done. It is for 20. We are writing electronic configuration for 20. So it should be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. That is for 20. So instead of 4s2, it is 3d2. Okay, it is 3d2. Means he is not following above principle. Why? What does above principle says? The incoming electron should occupy lowest energy state first. So if you take 4s now, so for this as it is told, you have to calculate n plus L value. 4s and given here is 3d. Therefore it is 4 plus 0 is equal to 4. While 3 plus 2 is equal to 5. So it should be 4s first because it is having least n plus L value. But what is given here is 3d2 is given. Therefore it is violating above principle. Then comes third one. Helium. Okay, helium atomic number is 2 and 1s2. He has also mentioned degenerate orbital with 2 electrons. One should be like this clockwise, other one should be anti-clockwise. But what happened here? Both are clockwise. So Pauli's exclusive principle is violated here. Pauli's exclusive principle is violated. What does Pauli's exclusive principle say? No 2 electrons will have all the 4 quantum numbers same. But if you consider this one, if you take this into consideration, right? N, L, Ml, Ms. These are the 4 quantum numbers, as you know very well. I have done a video on quantum numbers, you can check it out afterwards also. So the first electron and the second electron. For the first electron, for both it is n is equal to 1 only. This is 1. NLX, N, L and X. So this first one is n, so 1. First both electrons it is 1. And L is what here? S. Because L takes value 0, 1, 2 and so on. So S means 0. So for both it is 0 only, 0. 1 is clockwise, so it should be plus of. Sorry, ml value is 0. Because you have only one box, 0 ml value. Yeah, one should be clockwise plus of, other one should be anti-clockwise minus of. But what happened here? Both are in the same direction. Therefore, Pauli's exclusive principle is broken. Now we will see first case. Which one is violating half-bow principle? Yeah, which is violating half-bow principle? It is second one, which is actually we have to consider this as A, this as B, and this as C according to your given question. So B is violating half-bow principle. So which one is violating half-bow? B. Then which one is violating Hund rule? So A is violating Hund rule. Okay. And next, what is the next question? Which one is violating Pauli's exclusive principle? Pauli, it is C. Because both are in the clockwise direction. One should be clockwise, other one should be anti-clockwise. Otherwise, all the values will remain same. Otherwise, now coming to the fourth question is what? If there is any wrong among A, B, C, correct the electronic configuration. So the electronic configuration of B is wrong because it's for 20, isn't it? It is for 20. So 20 means it is 1s2, 2s2, 2p6, 3s2, 3p6 and 4s2. Instead of that it is 3d2. So it is wrong. Right? I'll come back with one more question. Second question. Yes. Second question. Question number 2 in information skill. Fill the given table with differentiating electron and the table is given with quantum numbers NL, ML, MS. Principal quantum number, azimuthal quantum number, magnetic quantum number and spin quantum number for these elements. Not for the whole electronic configuration. It is only for the differentiating electron. This is a very interesting point. Differentiating electron. So let us take aluminium. Now I told you in the previous question, you have to work out with this, then it will be easy for you. Given is aluminium. Aluminium atomic number is 13. So configuration is 1s2, 2s2, 2p6, 3s2. With this I finish 12. Then it is 13th one is 3p1. So I have to write the 4 quantum number values. That is principal quantum number, azimuthal quantum number, magnetic quantum number and spin quantum number for what? 3p1. So as I was telling you, p whole sum in box is 3. This is according to what? This is according to what? N, L, X. That means this 3 is N. So it is 3 over here. P means what? It is L value. P means it is L value. Now L takes value 0, 1, 2. S, P, D. Since it is P for you, so it's 1 over here, 1. So ML value is L value is 1. Now 1 is what here? P. P holds how many electrons? 6. How many boxes does it require? 3 boxes. Okay, 3 boxes are mentioned. Then what else to do? Give the magnetic orientation values. It starts from, as it is told, minus L, 0, dash dash L, plus L. I am recalling all that we finished in the previous videos. So minus 1, 0, 1. Why minus 1? Because your P is 1. So it starts with this L value, minus 1, 0 and 1. Okay, done. So how many electrons does it possess? Only 1. 1. So your magnetic orientation for this particular 3p1 is ML value is minus 1. How many electrons are present in this box? Only 1. So it's clockwise. So it is plus half. Now bring it over here. So it is 3. Then comes 1, minus 1 and plus half. This is the value for differentiating electron in aluminium. Now let us speak about the next one. What is next? Given one. he has given the electronic configurations. We'll check it out the configuration. It is 3, 1, 1 and plus half. First, in these type of cases, what we have to do is work out. Okay, this is regarding second one. What is given is ml, n, l, ml and ms. Values given are 3, 1, 1 and it is plus half. Now, when these type of things are given, you are supposed to write electronic configuration. Previous case, what happened? Element is given. You are supposed to write N, L, ML, MS values. In this case, particularly what different it is. N, L, ML and MS values are given. You have to tell which element it is. That means first thing what you should know, electronic configuration. Now we'll see how to know its electronic configuration. You should start from here. Yeah, dear students, it is made very clear. I am telling you very clearly that you should start from here. So it is P then, P. And then N, it's understood it is 3. Therefore 3P, very clear. P, why particularly to start from here? Because P has got 3 boxes. If you know this degenerate orbital magnetic orientation, only you can write the electronic configuration, because 3P means what? It starts from 1 and it ends up with 3P6. It may be 3P1, it may be 3P2, 3P3, 3P4, 3P5, 3P6. That many possibilities are there. That's why if you know if you know what actually it is, what is the azimuthal quantum number, to some extent you have solved it. What is the magnetic azimuthal quantum number 1? So it is P, then it is 3P, finished. That means you require 3 boxes. Till then it is finished. Now the ML value should be 1. Okay, ML value 1 means what? It has to go up to here. We'll put on. He is telling that whether sometimes I am explaining you very clearly. Sometimes why not like this 1, 2, 3, 4, 5 and 6th one, because it also come under the same magnetic orientation 1. That's okay. Now how to distinguish these two, whether this one, this is this one or this is this one. How to distinguish? It is plus half. Plus half means 1. Plus half means in this case it is clockwise. So this doesn't exist. Now directly you don't go to this electron, isn't it? Therefore you are going to fill the first 2 also. Therefore it is 3p3. So let us write the electronic configuration up to 3p3. 1s2, 2s2, 2p6, 3s2, 3p3. So what is the number now? 2 plus 2, 4 plus 6, 10 plus 12 plus 3. So it is 15. So it's phosphorus. Let me put a star for this. This type of thing is very important and very interesting also. Okay? Right. We have one more here to listen again. So, right, let us continue with the third one. Because we have one more. If you didn't understand this one, you can go back to magnesium also. Now coming to magnesium. Given. Magnesium is given, so work out, okay. Magnesium atomic number is how much? 12. So electronic configuration is 1s2, 2s2, 2p6. With this I finish 10 and 3s2, 12. So differentiating electron, what we are speaking about? 3s2 only. Directly we are speaking about 3s2. So Ml, Nl, Ml, Ms values are what? N, principal quantum number, azimuthal quantum number, magnetic quantum number and spin quantum number. S means what? You have got only one box, one degenerate orbital. Value of degenerate orbital is what? 0. So both electrons enter into the same thing. Therefore, as I told you previously also, NLX, these are according to NLX. So your N is 3, your L is 0, and the magnetic orientation of 0 is 0 only. S is 0, sorry. ML value is only one box, so it is 0. Now speaking about 3s2, you are speaking about second electron in the same box, second electron which is anti-clockwise. So let us take the values again. See, 3 here, 0, 0 and minus half. These are the values of magnesium when in the differentiating electron, that means last 3s2, you are speaking of 3s, not ts1, it is about 3s2. Now coming to this one, again you got a question, very interesting question, fourth question. This fourth question is similar to second one. So okay, we'll see this. What is given here? N, L, Ml and Ms. Values are 1, 0, 0 and minus half is given. What did I tell you? This type of question, first know what is this one. So it's S. Sorry, S, it's understood it is S first case. Then it is N value is 1. So it's 1 S pakka. S means you have to draw one box. And just now I told you, for S you need not worry anything. But interesting thing is what minus. So indicates that it is second electron. Second one means 2 are here. 2 electrons are here pakka. Okay? Then it is 1s2. Now let us check it out again. Let us check it out. So it's N, L, Ml and Ms. So 1, 1. S means I told you just now. S means simply remember it has got only one box and S means 0. Right? 0, 0. And the second electron you are speaking out second electrons minus half. Exactly same. So your electronic configuration is 1s2. Now 1s2 comes from which element? Right? So its atomic number is 1 only. Sorry, 2. 2. Atomic number is 2. So its atomic number is 2. 1s2. So it is for helium. Helium atomic number is 2. Therefore it is helium. Right? Very interesting, very important question. This type of question somewhat peculiar rather than this one. So you are speaking about what actually 1s2 second electron, that is a differentiating electron in helium. Right? We will come back to the third question. Now I am ready with the third question, information skill, third question in structure of atom. See, given question is 1s2, 2s2, 2px1, 2py1 is the electronic configuration of carbon. So he is telling that it is electronic configuration of carbon atom. Why it is not 1s2, 2s2 and 2px2? Explain like that. Okay. Now we will see. These two are not same. First of all, let me tell you, these two are not same. Right? I will make it clear now. So what is given electronic configuration of carbon? He is saying that it is carbon. So carbon atomic number is 6, 1s2, 2s2 and 2p2. Very good. So this is like first degenerate orbital holds 2 electrons. Second degenerate orbital for 2s2, it holds 2 electrons. P, as you all know, there are 3 degenerate orbitals. This will be px and this will be py and this will be pz with magnetic orientation -1, 0 and +1. Right, done. Now what happened? In the first case he is telling it is 2px1. So 1 electron over here, 2py1. So 1 more electron here. So on the whole what happened? 1, 2, 3, 4, 5, 6. There is therefore number of electrons are 6 electrons. Okay. Same way number of protons will be same 6 and number of neutrons will be same. That is a different story. Coming to this point, this is like this. Now he is saying, why can't it be? Why not? Why not? Why not? So we are answering your question now. We are answering your question. And in the beginning I told it can't be. These two are not similar. We will see. Given electronic configuration is 1s2. Therefore next one is what? 2s2. Next is what? 2px2. Now come on, let us draw. For 1s2, 1 degenerate orbital with 2 electrons. 2s2, because principal quantum number is different, 1 became 2, therefore second 2 electrons. Now p holds how many boxes? Degenerate orbitals are 3. And they are also represented as px, py and pz with magnetic orientation -1, 0 and +1. Okay, done. Now what is he saying? He is asking you to fill px2 with 2 electrons. Now to fill 2 electrons in px2, clear, it is so clear now. To fill 2 electrons in px2, then what happens? We have to first fill all the degenerate orbitals. Why? Hund rule. Pairing occurs only when all the degenerate orbitals are completely filled with 1 electron each. He is directly asking you to take 2 electrons in px2. That you simply cannot take. You have to fill all these first, then go for pairing. So on the whole, what happened? It has become 1s2, 2s2 and 2p4. And this is an electronic configuration for oxygen whose atomic number is 8. 8. 2, you can check it out here. 2 plus 2, 4 plus 4, 8. So how can these two be similar? What is the difference? Once again, let me tell you. He said it is directly 2p2. Directly 2p2 or else it is 2px1 and 2py1. Just let me clarify according to a question. What does this indicate? It indicates it is 2px1. What does this indicate? It indicates 2py1. So according to your question, right? So 1s2, 2s2, 2px1 only, 2py1 only, right? Therefore, what happened now? 2 plus 2, 4, 5 and 6. So it is 6 only. But if he is asking you to write 2px2 directly in px, you have to take 2. You have to take 2 in px means first you have to fill each one 1, then go for pairing. So it has become oxygen. That is the reason both of these two are not same. This is carbon and that is oxygen. A very interesting question. Okay, let us see the fourth question. Information skill structure of atom. Fourth question. This is a box given over here. So we have to fill this total box. What are the items to be filled? Subheadings are given. So a little bit what we have to do, as I told you already, you have to work out. You have to do little bit of workout and fill the same thing here. What is given is n value. See, n, if n is equal to 1, then L will be 0. 0 we represent it as S. Therefore, what it notation becomes 1s. 1, this is 1 and this is S. Therefore, it becomes 1s. That's one thing. 1s means how many electrons it holds? 2. First one is over. Same way it is next for n is equal to 2. Where L is equal to what? 0, 1, S, P. Now S holds how many? So it is okay. Notation is what? This is 2 and this is like this S. This is 2 and this is P. Therefore it is 2s2 and 2p, p holds 6 electrons. Right, done. Next, n is equal to what? 3. Therefore, L is equal to what? 0, 1, 2. So, what do we represent this as? S, P and D. So, nothing but how to read them along with this SPD. It is 3s, Vp and 3d. Now tell me, S holds how many electrons? 2, P holds 6 and D holds 10. Right, done. Next, N is equal to what? 4, where L is equal to 0, 1, 2, 3. That is what? S, P, D, F. Okay. So, how to represent them? 4s, 4p, 4d and 4f. S holds 2, P holds 6, D holds 10 and F holds 14. Right? Understood. It goes on. Now, N is equal to 1, so L is equal to 0. N is equal to 1, L is equal to 0. 0. And the ML values, I told you, remember? L is equal to 0 means what? S, you have only one box. So the ML value will be, ML value starts from minus L, 0 and plus L. So it's 0, only 1. L is equal to 1. We represent it as P. P holds how many electrons? 6. So how many boxes you require? 3. ML value is minus 1, 0, 1. Because it's 1. Starts with minus L and ends with plus L. Now L is equal to what? 2. 2 means what? D orbital. How many? 5 boxes. We require 5 boxes. 1, 2, 3, 4 and 5. L value is what? 2. So it starts with minus 2, ends with plus 2. Therefore minus 2, minus 1, 0, 1 and 2. Right, done. So ML value of this is what? 0. Next 2. Two values are what? 0 and 1. Therefore ML value of S is 0 and ML value for 1 is minus 1, 0, 1. Now what is this one? 3. N is equal to 3. N is equal to 3. L is equal to 0, 1, 2. L is equal to 0, 1 and 2. What is the ML value for 0? 0. So it's 0. What is the ml value for 1? 3 values, -1, 0, +1. What is the ml value for 2? 2 is given here. -2, it starts with -2, -2, -1, 0, 1 and 2. Now coming to fourth one, n is equal to 4. N is equal to 4. L values are 0, 1, 2, 3. So it's 0, 1, 2 and 3. So S ml value is 0. S ml value is 0. And for 1 it is -1, 0, +1. For 2 it is -2, -1, 0, 1 and 2. For -3 it is, for 3 it is -3, -2, -1, 0, 1, 2 and 3. Finish, this column is finished. Subshell notation. Here I mentioned subshell notation. This is your subshell notation. This is called subshell notation. This is called subshell notation. So it's here 1s. So it's 1s. This is 2s. 2s. 0 means s. So it is 2s. And this is 2, 1. 2, 1. 1 means what? P. So it is 2p. 2p. Finish. Coming to 3. 3, you know 3. It has got 3 values. 3s, 3p and 3d. How? Same. 3s. S means 0, isn't it? 1 means p. So it is 3p. 2 means it is d. 3, 2. That means 3d. 3d. Finish. Same way. 4s. 4s. 4p. 4d, 4f. Finish. Now coming to number of degenerated boxes. For S it is 1 box. So it's 1. So wherever you come across S, you can finish simply, you can finish 1. P has got 3 boxes. Degenerate means boxes. P 3 boxes. 3 boxes over here, 3 boxes, and P is here 3 boxes. D 5 boxes. Therefore you come across D here 5 boxes, and this is 5. And F is 7 because the difference is 2. 1s2, 2s2, 2p6, sorry, not that one. S holds 2 electrons, okay, P holds 6 and D holds 10. So the difference is 4, therefore F holds 14. Finish. 14 means you require 7 boxes. Finish. Number of electrons. In one box, how many electrons will be there? 2. So for L is equal to 0, you are getting 1 box, isn't it? So you, how many? L is equal to 0 means S orbital. S orbital 1 box means 2 electrons. 2 electrons. So whenever you come across 1, you just mention 2 electrons. Finish. Because these are called boxes. 1 box will hold 2 electrons. 1 box will hold 2 electrons. Now 3 boxes will hold 6 electrons. Quite natural. 3 boxes will hold 6 electrons. Here 3 boxes are there. 1, 2, 3, 4, 5 and 6. 6 electrons. Nothing but it is P. Nothing but it is P. P. You check P. P. You have to check this P. P. P holds 6 electrons. So here P again 6 electrons. D holds 10 electrons. So 10 electrons. Why? Because number of degenerate atoms are 5. 5 2s are 10. So it is 10 and 10, and the last and final is 14. 7 2s are. The other way also we can discuss this one. The number of degenerate orbital boxes formula is 2L plus 1. And if it is for number of electrons in degenerate, this is degenerate orbitals, boxes. Formula is this one. Number of electrons in degenerate orbital means it is into 2. 2 into 2L plus 1. So you got it as 1 here. 1 into 2 is 2. So wherever you get 1, it is like 3. Why did you get 3? It is P here, P. So P means 1. 2 ones are 2, plus 1 is 3. 3. So 3 into 2 is 6. Right? Thank you. Subscribe my channel. I'll give you more and more information. Thank you. Now let's see a fifth question in information skills, structure of atom. A very interesting question. You can look it on the board. What is given here? Give the name of the element. So you are supposed to give what? Name of the element. You have to tell the name of the element. Okay? Element, its atomic number and electronic configuration. So 3 things you have to say. One is what? Name of the element. Other one is its atomic number and its electronic configuration. How can you say name of the element, electronic configuration, atomic number without anything, without any clue? Therefore he has given the clue. These are the 4 clues. He is saying that the first one is the last electron will be in the second shell. second shell. So what we need to do, we have to work out, a bit workout should be done. Now workout, first one is what? First clue is saying that it is in second shell. So it's understood for us n is equal to 2. Yes, clearly understood that it is n is equal to 2. The next one lies in, it lies in p orbital. Therefore p orbital is also confirmed that it is 2p pakka because second shell p orbital. Now coming to p orbital has got how many boxes? Degenerate orbitals 3 with a magnetic orientation value is what? -1, 0, 1. These things I clearly explained you in quantum numbers. Okay, because L value, whatever the L value is, it starts with minus, ends up with plus. Write that. Now coming with that, with this much knowledge, it's not enough to say which element it is, what is its atomic number, electronic configuration. So let's go to the third one. Third one says that its ml value is 1. So here it is here. ml value is 1. So it's clear that electron is going to come in this one. But why am I not filling it here? How can I fill? Because suppose when you speak about when it is 3, okay, 3. Since confirm it is ml value is 1, I can fill it like this, right? In this way. So 1 each and then pairing. So according to this, I will get the number as 2p6. Maybe, may not be 2p6. Why? Because if I don't pair them, then this will be the number 1 each. Why? Because he said that third one that ml value will be 1. That much only. He didn't say that it should be paired and it should be sixth one, like that, nothing. So sometimes what happens, it can also become 2p3. Now how to confirm? Fourth point is very important. Super important point is fourth. What is he saying? That last electron is anti-clockwise. Yes, finish. Anti-clockwise means like this. Now when will you get the anti-clockwise? You will get the anti-clockwise only when all these are filled 1 each and then pairing starts and ends up with the last one, 1. ml value 1. So on the whole it is 2p6. Now let's write down the electronic configuration up to 2p6. It is 1s2, 2s2 and 2p6. Now how many? 2 plus 2, 4 plus 6 is 10. Therefore atomic number is 10. So what is your first question? Which give the name of the element. So 10 means what? Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. So it's neon. Neon is your answer. Element is neon. Atomic number of neon is how much? 10. What is its electronic configuration? So I am writing electronic configuration for 10. 1s2, 2s2 and 2p6. Finish, right? This is the answer. So the element is neon. Atomic number is 10. And the electronic configuration is 1s2, 2s2, 2p6. Subscribe. If you have any doubt, right, please comment. Thank you. Now let's discuss about sixth question in information skill. What is that sixth question? In an atom, the number of electrons in N shell is equal to the number of electrons in K and L shell. So these are the questions. First of all, we'll see what is it told. The number of electrons in N shell is equal to the number of electrons in K and L shell. Actually, you need not know, you will not know also how many electrons he is speaking about in N shell. But one thing is clear, that the amount of electrons in K and L is equal to M shell. That much it is clear. So K holds how many electrons? 2. L holds how many electrons? 8 electrons. How? So it's like this. This is nucleus, first shell with 2 electrons and second shell with 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. So that's what it means. So this is K shell with 2 electrons, L shell with 8 electrons. So on the whole it is total, how much it is? Total number of electrons, 10 electrons. So he is saying that N should also hold 10 electrons. Now you tell me which element you are thinking about. So N should hold 10 electrons. Why? Because number of electrons in sum of electrons in K and L is equal to M. Sum of electrons is how much? 10. That is equal to M. Then what is the element? Can you tell me? Most of the students guess it is calcium because 10 plus 10 is 20, but it is wrong. The actual element is, now we'll see on the board. So he's telling that M should hold how many electrons? 10. First of all, N is equal to 3, means it is M. Because N is equal to 1, 2, 3. This is K, L and M. So N is equal to 3, M shell. That means L is equal to what? 0, 1 and 2. S, P and D. Let's write down the same thing now. That means it is 3s, 3p and 3d. So now how many electrons we are supposed to share within these 10? Because he is telling no, M is equal to 10. So it is 2 over here because S holds 2 electrons, P holds 6. That's all finished. Completely S holds 2, completely P holds 6. Now leftover is given to D. 3D2 according to its value. N is equal to 3 means N is equal to 0, 1, 2. They are read like this, right? 3S, 3S, 3P, 3P, 3D, 3D. So number of electrons to be shared here is 10. S holds only 2. P holds 6. Therefore, the remaining 2 is given to D. Now let us write a configuration, electronic configuration such that we get 3D2. Therefore, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d2. In order to get 3d2, we got 4s2 extra. With this, the atomic number has gone to atomic number of this element has gone to, can you just add up 2 plus 2, 4 plus 6, 10, 12, 18, 20, 22, it is 22. Therefore, it is titanium. Titanium is the element. Very interesting question. Most of us think it is 10 plus 10 is 20 and calcium. So it is this way.